Alright guys, welcome to part 3. So we're going to do a very fun problem right here and I'm pretty excited. So we have a hydrogen atom and it orbits a proton, so let's pretend this is a proton. And it orbits it with a radius, so this is the radius. So the radius R is 5.29 times 10 to the negative 11 with a period of, and I'll see what's going on, with a 1.52 times 10 to the negative 16 seconds. So what is the electrons, they call it centripetal acceleration. Okay. So given the radius and this period, which is essentially like the speed in which it revolves once. So it's kind of weird. So the base, to kind of simplify the complicated nature of this, this is no ordinary like regular physics problem. This is dealing with like anything with a radial acceleration. So usually we use a different set of formulas when we deal with anything that goes like radial or around a circle, or they call it the curvature, I think, if I remember, the curvature radius. So you cannot use like kinematics or like the normal physics equations. So what we do first, we use this formula. The speed is equal to 2 pi r over the period, and this will help us find the speed. Because you have the v, which is this, and you have period, which is this. So when you plug it all in, you have this 2.19 times 10 to the 6 meters per second. So that's a pretty big number. Then from there, you find the acceleration from using another unique formula that's only applied for centripetal acceleration, which is v squared over r. And again, you know r and v squared is just this. So once you calculate all that, your a is simply, and it's going to be a big number, so don't be surprised if when you do it, it comes out big, because it is a big number. 9.07 times 10 to the 23rd meters per second squared. This is the 23rd. Oh, I'm sorry, 22nd. I screwed up. Sorry about that. And that's it. So usually when you get a problem that says what is what is a curvature acceleration, what's the centripetal, or what's anything that has a radial acceleration, just remember that you're going to be using different sets of formulas that are this would not work if you were trying to find like another type of speed for a car, because the car doesn't go, unless it says that the car is going in a radial direction. You cannot use this formula, and you cannot use this formula at all. So these are very, very specific to certain situations in physics. And yeah, I mean that's all there is to it. We'll go on to part 4 and then we'll finish up with part 5.